Good morning to everyone. My name is LOHITH.S and I am currently studying BTech first year in the Department of Computer Science and Engineering. Today, I am going to present a topic related to chemistry which plays a very important role in the modern industrial world. The topic of my presentation is addition and condensation of polymerization. In this session, we'll understand what polymers are and how these two different types of polymerization takes place, their mechanisms, examples of each type and their properties, and also how they affect the environment. Now, I would like to begin the main topic starting with an introduction about polymers. Polymers are extremely large molecules made up of many small repeating units called monomers. These monomers join chemically to form strong chain-like structures. We commonly come across polymers in the form of plastics, rubber, fibers, adhesives, and various household and industrial materials. In chemistry, polymer formation occurs through different processes, but two of the most important methods are addition polymerization and condensation polymerization. Now today, understanding these methods helps us know how different materials can be produced and why they have unique properties. Next, we'll go through the addition polymerization. The addition polymerization means it is a chemical reaction where monomers having double bonds add to each other without producing an byproduct. The monomers simply join one after another and form a simply join one after another and form a long polymer chain. This reaction generally involves alkenes and ethene and propene or vinyl chloride. Because the monomers directly add to each other and the chain grows continuously. This process is also known as chain growth polymerization. Next, I'll go through the conditions required for this type of polymerization. The conditions required for addition polymerization, certain conditions are: first, the monomer must contain a double bond. Second, high temperature and high pressure are usually required. Thirdly, catalysts such as benzoyl peroxide or Ziegler-Natta catalysts are used depending on the monomer. Sometimes ultraviolet light or heat also starts the reaction. This condition helping in breaking the double bond and allow continuous chain with growth. Next, we'll go through the initiation step of the mechanism. In initiation, in the mechanism, the reaction begins with the formation of free radicals. These free radicals are produced from initiators such as benzoyl peroxide and etc. Free radicals are highly reactive, so they immediately attack the monomer molecule and break the double bond. This produces a reactive monomer radical, which is now ready to start the chain. Next, we'll grow the propagation, and this is the propagation step. In the propagation, the active monomer reacts with another monomer, forming a long chain. This process continues many times. Thousands of monomers may join in a single polymer chain as long as free radicals are available. This is the important of the mechanism propagation. The chain keeps growing rapidly. Next, we'll see the reaction stops when the termination. The termination is nothing but as death of the cell. In termination, two free radicals combine, which stops further chain growth because chain termination happens at different stages. Polymers of different molecular sizes may be formed. This results in different physical and mechanical properties of the final polymer product. Next, we'll go to some examples of addition polymers. The examples of addition polymers includes polyethylene, PVC, polystyrene, and Teflon. They are extensively used in household materials, industrial applications, electrical insulation, and packing products. And next we'll go through the polyethylene in detail. Polyethylene is produced by polymerizing ethene. It is one of the most commonly used plastics worldwide. It is lightweight, flexible, resistant to chemicals, and it is used in plastic bags as we regularly use them, and it is a flexible resistance to chemicals, and it is used in films and containers, water bottles, and packaging materials. Polyethylene can be made as HDPE or LDPE depending on density. Next, go through PVC. PVC is nothing but polyvinyl chloride. It is produced from vinyl chloride as a monomer. PVC is very strong, durable, and resistant to chemicals and fire. It is used in water pipes, cable insulations, floorings, and toys, and electrical applications, etc. Because of its strength, it is widely used in construction also. Next, let us begin through the general properties of addition polymers. Addition polymers are lightweight, chemically resistant, and durable. They do not react easily with acids or bases, therefore last longer. However, most of them are non-biodegradable and create environmental pollution, especially plastic waste. Next, we'll go through the condensation polymerization. Now, in this topic, we need to have a question and we need to arise a question that what is condensation polymerization? Condensation polymerization is a chemical reaction in which monomers join together by eliminating small molecules such as water, HCl, or alcohol. The monomers contain functional groups like COOH, NH2, or OH. In this reaction, mostly forms long-chain polymers used for making fibers and engineering plastics. Therefore, the process is also known as step growth polymerization. Next, we will go through the conditions necessary for this process. The conditions necessary for condensation polymerization requires monomers with two functional groups and with high temperature and sometimes an acidic or catalytic medium. Since a small molecule is removed during every step, the polymer chain grows step by step, takes more time compared to addition polymerization. Next, we'll go through the examples of condensation polymerization. The examples of condensation polymerization includes important condensation polymerization includes nylon, polyester, bakelite, and many other polymers and polyesters. These materials have excellent strength and are widely used in textile industries and engineering applications. Next, we'll go through the nylon 6,6. Nylon 6,6 is produced from adipic acid and hexamethylene it contains strong amide linkages and hydrogen bonding between chains, giving it high tensile strength. It is used for ropes, parachutes, gears, mechanical parts, and many other things, and like synthetic fibers. Next, we will see polyester. Polyester is as PET. It is commonly known as PET. PET is introduced from ethylene, glycol, and terephthalic acid. It has great transparency, great strength, and moisture resistance. It is used in bottles, fabrics, packing, sportswear, and plastic films. Next, we'll go through the bakelite. Bakelite is a thermosetting polymer made from phenol and formaldehyde. It becomes permanently hard after modeling and cannot be reshaped. It is used in switches, electrical plugs, handles, and heat-resistant products, such as in when we see the utensils which we have in the kitchenware, the handle which is located for the pan, it is also made from the bakelite. Next, we will go through the properties of condensation polymers. The properties of condensation polymers are they are strong, they are heat resistant, and they have high melting points. Some of them show partial biodegradability. They are generally used in fibers, textiles, engineering components, and heat resistant applications. Next, we'll go and we'll compare addition and condensation polymerization. The difference between addition and condensation polymerization are it needs double bonds. Addition polymerization needs double bonds, produces no byproduct, and grows rapidly, while condensation polymerization needs functional groups, produces a small molecule, and grows gradually. Addition polymerization are mostly non-biodegradable, while some condensation polymers are biodegradable or recyclable. Next, we'll go through applications. The applications of polymers are used in packing, construction materials, textiles, automotive parts, household items, and electrical components, etc. Addition polymers are used mostly for plastics, whereas condensation polymers are used for fibers and engineering materials. Next, we'll discuss the environmental impact. The environmental impact had many impacts nowadays. Many addition polymers remain in the environment for a long time and cause plastic pollution. They are harmful to soil, rivers, oceans, and as well as for the marine life creatures. Therefore, recycling using biodegradable polymers and reducing using biodegradable polymers unnecessary plastics is extremely important for environmental protection. Now, we'll come to the conclusion and we'll end up this session as to conclude polymers are essential materials used in daily life industries such as they both addition and polymerization, condensation polymerization processes have different mechanisms, examples, properties, and environmental effects. Understanding these processes allows us to make informed choices about the material we use and encourages us to adopt environmentally friendly and alternatively. Hope I think everyone understand this addition and condensation polymerization applications and their everything. Thank you.